Hello students, if you're viewing this video, you're now about to be introduced to how to analyze the data that you obtained from the sieve test, the sieve analysis you performed as part of Lab 1 or Assignment 1 for your Geotechnical Material course. I have included for you a sample test data that's been obtained from a sample sieve analysis. You can see it right here. You can also find this data under Blackboard as follows. You can go to your Blackboard page for your ENG8454 Geotechnical Materials course. The fastest route is to go under Assignments in Lab, find Assignment 1, review some of the information related to Assignment 1. I'm sure by now you've already reviewed what Lab 1 comprises. You've reviewed the appropriate pages in the textbook with a step-by-step instructions. You downloaded a blank Excel chart. And here is the sample sieve data and analysis that I'll be using for you. If you click on this, that's the data that I'll be working with. And once this video is completed, actually, you'll have a video right here that will describe to you how to follow along with me on analyzing this sample data. So the idea of this lab is to use one of the tools at our disposal, a sieve test, to determine or to identify what the material is that we've just graded. For the lab in particular, we're going to try to answer the question of whether or not this is a granular A material. So in our case, we've obtained this data from our analysis. Here is the list of the sieves that will be used. Now the list of your sieves is slightly different, as I'll show you in a moment. And these are the imperial designations for the sieves that we'll be using. It's basically a designation of the opening sizes in each sieve. Adjacent to it, you'll find the metric designation of the opening in millimeters. And this is the important column that you have to make sure that you measure correctly, that you weigh correctly during your lab. It's the amount of material that's retained for each sieve. And the way that you obtain each one of these is once you take each sieve, after you shake all the sieves with the material in it, one at a time, you're going to weigh the material that's retained in that sieve only. So be careful. You're not recording here the weight of the sieve and the material, but only the weight of the material that is in that specific sieve. So what that means is that if you're setting up your lab correctly, and if you have followed the directions and instructions provided in the Lab 1 video and the instructions in your textbook, you will have weighted or weighed the weight of the empty sieves. Otherwise, it's going to be very difficult for you to weigh these. It's a good way for me too to see if you've actually reviewed these instructions. If the first thing you do before you proceed to shaking your sieves is to weigh each of these sieves empty. Alright, so what I'm going to do then, while keeping in mind what the end goal is, I'm going to switch over to using the spreadsheet that I provided for you. This is a blank spreadsheet that I've printed from that Excel document I've given you. So I'm just going to switch the two. And the first thing I'm going to do is grab a pencil, a trusty Algonquin College pencil, and start filling in some of the important information in the spreadsheet. You're going to notice a time lapse, as I'm not going to keep you looking at this video as I fill the whole thing. We'll be back in a few moments. a couple things that I'd like to bring to your attention. First of all, the sample weight. So this is how much mass of material you're going to dump into the stack of sieves. Okay, so this is the original sample weight. You want to make sure you have this sample weight before you dump it on top of your sieves and shake it. Very important. Then here I've transcribed the amount retained in each sieve, which you can compute by, after you shake all your sieves, weighing each sieve with the material and subtracting the weight of the empty sieve from it. Here's the weight of the pan, so any material that's so fine that passes the 200 sieve. And here I've added up all the material that I've recorded. Do you notice something interesting? The total amount of material that I got out of the sieve analysis is actually less than the total amount of material I started with. It's about 1.44 grams less. So here's a question. Why is that? That looks like a potential source of error. A very important question is, why is that? You'll notice that as part of your rubric for this test, for this lab, which we'll discuss the following week, is to identify the sources of error and how they impact your analysis. So feel free to approach me and we'll discuss possible reasons why this has happened. Another important thing, notice how at the top here I indicate that this is in grams. That means you don't have to write grams in here, because the whole thing here is in grams. So I want to be clear, you don't have to write this in grams. It's already identified as being right there in grams. Similarly, over here, this is already identified in grams, so you don't have to write this as being in grams. That's an easy way for me to dock marks from you, and we don't want that. Very well. Now, the other thing we're going to do now is start filling in these other columns, one at a time. Let's start with total retained. Total retained identifies how much of the total amount of the sample has been retained in any sample sieve size or higher. And this is how you calculate it. The top one is easy. You just write whatever the amount is in that column, 0 grams. The next one is that amount plus that amount. So in our case, 0 plus 0 equals 0. And then you repeat the same thing as you go down. It is the one next to it plus the one above it. So the one next to it is 0 plus the one above it is 0, we get 0. Okay, it's a total amount, the total weight of material that's been retained by this sieve and above. So here is the one next to it, 0.59, plus the one above it, which is 0, equals 0.59. For this one here, it's the one next to it, 0.4, plus the one above it, 0.59, equals to 0.99. I'm now going to fill in the rest, and by the magic of cinema, you won't even notice. So I encourage you to see whether or not you can get the same numbers as I have. Notice how I didn't write grams anywhere because I identified this column as being in grams. And to check, this number here in the pan should be the same as that number there that you obtained. It is in this case, so it looks like I've done things correctly. Again, I'm using a pencil in the event that I make a mistake so I can easily erase it. If you feel comfortable, you can do it in pen, but please note that I won't look keenly on a submission from you where there are scratched out items such as this, or a poorly erased item such as, for example, this. right? That's a poorly erased item. I expect a professional submission on your part, so perhaps you can do what I'm doing right now, write this out in pencil, and then I'll transfer it in pen to a blank sheet like this. Now we want to fill in the next table, right here, the next column. This is the total passing. So this is essentially the opposite of what we calculated here in this column for total retained. So we want to identify the total weight of the material in grams that is passing that specific sieve. And this is how you calculate it. For each cell, it is this total, so 546.44 minus this cell. Ready? Okay. So it's minus 0, so this number here is 546.44. Then, for this number here, 546.44. Okay. So this number here is still the same, 546.44. And this number here is 546.44 minus 0.59. So that comes out to be 546.44 minus 0.59, and you can fill that in. And now I'm going to fill in the rest.